today we're going to do the Tollens Test, which is a test to see if we have a reducing sugar or not in a solution. We use silver nitrate reacting with ammonium hydroxide to create an ammonium or silver ammonium complex, and we react that with the reducing sugar. So what happens eventually is, in the reaction between the silver complex and the reducing sugar, silver is being reduced down to silver metal, and it's being plated on to the sides of a glass container. What we're going to do here is I'm going to take this Florence flask, and it has a little bit of distilled water in it. I washed it out earlier today, but we're going to use this and we're going to show you the proper steps of doing this. Okay, so in a couple seconds here, we'll go step-by-step process in terms of making the solution and how to go about having the reaction occur within the flask to produce the silver metal on the inside of the walls of the glass container. Okay, first step into doing this demo or this experiment is to get some type of simple sugar like dextrose or glucose and create a solution of it. We have made a solution, or I made a solution of dextrose this morning, and the only thing we need is about 5 milliliters of the dextrose, and we place this into our flask, and then this is going to set off to the side for a few moments until we create our Tollens solution, which is what we're going to be making here in a couple seconds. All right, we're going to create now the Tollens solution by taking silver nitrate. I believe this is 1.1 molar. And we're going to add ammonium hydroxide to this. Now, when we add the ammonium hydroxide to the silver nitrate, we're going to see a brown color being produced. I joked around this morning with my students and say it's more of a baby diarrhea looking brown color. But as you add more ammonium, the ammonium compound to it, it will dissolve and it will actually go colorless. So let's show you what happens with this. So in this pipette I'm pipetting up is ammonium hydroxide. So I'm going to add this to, and you should start to see a brownish looking residue being formed. And if I swirl it enough, it will go away. So what we have here is a colorless solution now. Add a little bit extra there just for the safety sake of it. Now, after we have made the silver nitrate and the ammonium hydroxide together and it goes colorless, we add a little bit more hydroxide, and this is in a form of potassium hydroxide. I've seen sometimes sodium hydroxide being used, but potassium hydroxide, we add that to the solution too. Now, if by some reason it goes brown, like it's doing now, we add more ammonium hydroxide until the color goes away. Okay, so now here I have my Tollens solution ready. Always make sure you wear your safety goggles, and considering we're using ammonium compounds, make sure you are using a fume hood. My fume hood is not on right now, but I'm the only person in here and I can't smell anything to begin with, so we're all good. Gloves might be used on this. The silver nitrate will develop your hands. It was used in black and white photography for many years. So if you get it on your hands and go out in the sunlight, you'll have splotchy hands for a few days, but it'll go away. So we have then our Tollens solution we just made. We have our flask with our reducing sugar in it. So what I'm going to do is I'm going to take half of this, or roughly 50 milliliters of this, add it to my flask, and I'm going to seal it off, and I'm going to agitate this. Okay, so we're going to do that here in just a couple seconds. Okay, I just poured 50 milliliters of my Tollens solution from my beaker into a graduated cylinder. I'm going to add this to the flask with the reducing sugar in it. I'm going to stopper it off, take a little bit of parafilm wherever I laid it at, and I'm going to seal off the top because all the stoppers I have that are big have holes in them. And I'm going to see and shake. Now, if you notice here too, within the flask itself, is it gotten dark, and we're going to shake this for a little bit of time. And what you should be seeing after a minute or two is you should start seeing inside of this flask should start getting mirrored in terms of what it should look like. So we hold it, we keep on shaking. Might take a few minutes, so bear with me, and maybe. Sometimes too, the reaction is temperamental. Sometimes students do it in the wrong order, or they have a dirty bottle they use. We use bottles, or a dirty flask.
One minute, 37 seconds later.
Sometimes the shaking will take the longest part to do. And you should see that your solution should get somewhat dark. Making sure you still have your hand over your flask very tightly. And what you should see here directly is the inside of your flask starting to get mirrored.
The Tollens test is a chemical test used to differentiate reducing sugars from non-reducing sugars. This test is also called the silver mirror test based on the end product of this test. The objectives of the Tollens test is to distinguish between reducing from non-reducing sugars and also to detect presence of aldehyde containing carbohydrates and differentiate them from the ketones containing carbohydrates as well. 15 minutes later.
Yeah. Sometimes it takes a few moments for it to actually kick in too. Starting to see a little bit of a mirror show up there. Normally my classroom does these with pop bottles or a glass bottle of their choice.
Meanwhile,
starting to see it, the mirror starting to show. You're not seeing much of the liquid anymore, it's starting to get mirrored. It's getting there.
Eventually.
If you notice here too, now we can see, of course you can see me recording myself. You can see the back part of my classroom. All my students have left for the day. Older Florence flask, I cleaned it out this morning. Not the best mirror, but you can tell it mirrored. The stem of the flask is pretty nice. The ball part too, you can tell too, there's a line in which went around with something from God knows how many years ago it's been in. All right, when we're done, we rinse it out with distilled water to make sure any excess chemicals that are in there can get gotten rid of. All right, this is my first science video I've done to post, so give me a like, give me a comment or two, and also watch my other content. I'm a big Funko person, so I'm a collector. So we're going to do some more science experiments like this and post them later on, and we also will do some gardening stuff and some other things like that too. So until next time, guys.